Everybody, welcome back to another fun and exciting geometry class. Today we're going to keep going in chapter number 4. We're going to be on page 194 today, and we're going to be talking about the fundamental transformations of proportions. Last lesson, what we talked about are basically the things that you can't do. It's like it's kind of like the laws that govern it. You can't go outside of those laws. In this lesson, we're going to talk more about the ways that you can work with the proportions, what you can do, how you can move things around, change things, add things, subtract things, all these different things that we're going to do to it. So let's go ahead and jump into it. Take a look at the screen. Transformation number 1. In transformation number 1, now there's a lot of text in the book. If you look on page 194, you're going to see transformation 1 has a lot of text. I narrowed it down to one word, okay? So if you look at it, alternation. That's the only word that I pulled out of it. Here's what it means. To alternate is to switch back and forth between something. So A, B, B, A, C, A, A, C. We're alternating back and forth with A, C, and B, C, and A, B. All right? So basically switching them back and forth. What does that mean for a proportion? Well, what we can do, if we have A over B and equals C over D, as long as we alternate these, here's what I mean by that. AC is alternating, okay? And BD is alternating. What does that mean? Well, we could say C over D equals A over B. That would, A over B. Sorry about that. That's my dyslexia kicking in right there. I'm saying D and writing B and saying B and writing D. And I'm sorry about that, but that's just the way it works for me. So what you could also say is you could say, another way to alternate these is you could say that AC, because those are together, you could say A over C equals B over D. That's fine, okay? And this is going to be very valuable to you right here, this alternating these things. Very valuable. Let me show you one that you cannot do, okay? What you cannot do is you can never alternate crossways, all right? So that's like, for example, I couldn't say A over D equals C over B. That's not going to work. I can't switch these two. I can't make these. They were up and down. These were up and down. I can't make them diagonal. This is wrong, okay? Now, the places that I could put B, the things that I could do, the alternations that I could make, is if it's up and down, I could take it and I could put it here. So I could say A and B, or I could say A and B like this. Either way, A and B have to be next to each other or up and down. So I could say this, B over D. That would be fine. But what I can't do, I always would have to have these be, the means equals the extremes, right? And why does this work? Let's go back and say, well, why does this work? Well, it's commutative. What does commutative mean? It means we can switch things around. 2 times 3 equals 3 times 2, right? We can switch those around. It doesn't change anything. So in other words, what we can do with the means and the extremes is we can switch them. So in other words, as long as we keep A and D together and we keep B and C together, okay, we could write it like that, or we could say DA equals BC. We could also say it DA equals CB. We could just switch that. So we can alternate things as long as we do something. Something is very important. We keep A and D together, and we keep B and C together, okay? And you'll see how that works as we continue to go through this. I probably didn't do a great job of explaining that, but I think that us working on the problems and you working on the problems, you'll be able to see how this works together, okay? All right, next one. Inversion. Transformation number 2 is inversion. To invert is to flip. And really, I kind of already explained that. So inversion and alternation is really the same thing, and I just explained it all at one time. If you look at the analysis on page 195 for transformation 2, it says same as in transformation 1. In other words, that principle is the same thing. Alternation and inversion are the same thing. What I did was, what you can do is you can invert these, and I did that. B over A equals D over C. That's inversion. Okay. So again, as long as you keep A and D together, and as long as you keep B and C together, you can move them around however you want to move them around. Okay. But you cannot mix them up. You can't say, oh, I'm going to put A and B together. No, you can't do that, because that's that. Now you're switching the means and the extremes, and now you've messed up the proportion. Okay. All right, inversion. So that one kind of took care of itself. Number 3, this is the addition property. So we have A over B equals C over D. We're just going to keep going back to that one over and over. Okay, so what we can say here is that A plus B over B is proportional to or equal to C plus D over D. We can take this bottom one and we can add it to this, and we can take this bottom one and add it to this. Now that one might be a little bit hard for you to understand, so let's go ahead and use some numbers. Let's use the numbers 1, 2, 3, and 6. Okay, so that's proportional. So now let's add it together. Let's do exactly what we did over here. So 1 plus 2 over 2 equals 3 plus 6 over 6. So in other words, I just took A plus B. So A plus B was right here, 1 plus 2. And then I took C plus D. That's right here, 3 plus 6 over B and over D. Let's see if these are still proportional. Well, what is 1 plus 2? That's 3 over 2 equals or is still proportional to. Now, notice we changed the value. It's okay. We're not talking about changing the value. We're talking about, is it still proportional? And the answer is yes. That is equal to 9 over 6. Go ahead and reduce that. Reduce 9 over 6, and guess what you get? You get 3 over 2. So that is still proportional. They're still equal to each other. Because look, if we reduce this, divide this by 3, we get 3. Divide this by 3, we get 2. Okay, so if we divide by the same number or the greatest common factor, we get it's still proportional. Now, we changed the proportion, didn't we? We went from 1/2 to 3/2. So the proportion is different, but it's still proportional to each other. They maintain proportionality, even though we did change the proportion by adding. Okay, transformation number 4 is subtraction. So if we take A over B equals C over D. All right, there's our kind of our one that we keep going back to. What does this mean? Well, with subtraction, it means that we're going to basically just subtract the B term. So we're going to have A minus B over B equals C minus D. Sorry about that. Over D. There we go. And it means that it's the same as the addition. Well, let's see if it works with this. Let's try it again. Let's put 1 over 2 equals 3 over 6. Let's use those same numbers. And we're just going to plug it in. So we're going to say 1 minus 2 over 2 equals 3 minus 6 over 6. All right, let's see if this works. 1 minus 2, I'll write this in a new color. 1 minus 2 equals negative 1 over 2. And that's proportional to negative 3 over 6. So really, we're back to where we started from here, but we're on the negative side of things, but it's still proportional even though it's negative. Again, we changed the value, but we still maintain the proportionality between the two. Okay, so you can do that. You can subtract the B term and the D term from the A and the C term, and you end up still maintaining proportionality. That's going to be really important in geometry over the next little bit. These things are so key right here. So even if you don't like really totally get it, it's important that you memorize it, that you memorize the fact that you can do this and it does work. As you practice this, I think you'll get it more and more. You'll understand it more and more. Transformation number 5 is exponentiation, and that is on page number, sorry about that, my book is all twisted up here on me, 196, page 196. So let's finish up the lesson with this one, transformation number 5. I wrote the word exponentiation. It's not technically the right word, but I like it, and so we're going to use it. So how do you do this with exponents and with roots and powers? You can do it, and let's go ahead and see how it works. So if we have our A over B equals C over D, all right, that's our go-to, we can prove that A to the n power, what's the n power? Whatever power we give it. Okay, so it's going to be the same. So if we say n equals 2, then all of them have a 2. So then we have b to the n equals c to the n over d to the n. So all of those are going to have the 2 as the exponent there. Well, now again, our value changes, but if you watch, our new proportion stays proportional. It doesn't lose its proportionality. 1 over 2 equals 3 over 6, going back to that basic proportion again. So over here we have 1 squared because we said that n equals 2 over 2 squared equals 3 squared over 6 squared. And again, these aren't going to be equal, but they're going to be proportional. What does that mean? Well, let's find out. Let's do it. What's 1 squared? It's 1. What's 2 squared? It's 4. So now we have 1/4. Again, they're different fractions. They're not the same. We're changing the fractions, but what we're doing is we're maintaining the proportionality between these two new fractions. Equals, what's 3 squared? 9 over what's 6 squared? 36. Okay, now let's check this. Notice that we can, our common factor is 9. 9 goes into both of those. 9 goes into 9 one time, 9 goes into 36 4 times. We maintained our proportionality between those two, even though we manipulated them by exponentiating them or multiplying them by an exponent. You can also do it with roots by square rooting them, and it also keeps the proportionality by square rooting. Okay? Well, that's all I have for you. Hope you learned something. If not, make sure to slide that back and watch that again. You might need to watch some of those again so that you can remember those, but we will be using those quite a bit over the next few lessons. All right, we'll see you later. Have a good one. Bye-bye.